So you guys heard the message, right? Okay, very good. All right, so going back to the problem, cube root of 1 would be 1, cube root of 8 would give you 2. So this would be your answer for the cube root of 1/8. Now, here's another one, guys. Negative cube root of 27 over 125. So on this one right here, you would keep the negative on the outside of the radical. And the cube root of 27 is what? What's the cube root of 27, guys?
3.
That one is 3. The cube root of 125 is 5. And that's it. So negative 3/5 would be your answer. Okay, now, I would go on to some perfect fourth roots. You know what, let me just say something about the fourth roots. You can see any type of root, guys. By the way, this in here is referred, you know what, let me just do this. Let me just do this. If you have a problem like this, okay, nth root of x to the m power. This, the symbol, is referred to as the root or the radical. Now, what is inside the root is referred to as the radicand. And so here the m is referred to as the exponent. Now, we need to know these components, guys, because of the next lesson we're moving to. So pay careful attention to the vocabulary. Now, this right here, the letter n inside the radical or the root symbol is referred to as the index. Now, when the index is empty, it is equivalent to 2. It's referring to the square root, okay? The square root. So you just saw some square root problems, some cube root problems. Just remember, this right here is called the index. It can change. When it's empty, it's equivalent to 2. So that would reflect a square root. Now, you just saw some cube roots. And now I was about to mention the fourth root. Now, the fourth root, guys, is the same thing as taking a double square root. It's the same thing as taking a double square root. So, for example, if I were to ask you to simplify the fourth root of 16, and you didn't know how to do this, you could do this. You could do a double square root of 16. So the double square root of 16 works like this. So first, you take the square root of 16. And when you take the square root of 16, what do you get? 4, okay? And then you take the square root of the 4, and the square root of 4 is 2. So pretty much the fourth root of 16 would be equivalent to 2. So guys, if they were to ask you to find, let's say, the fourth root of 81, what would the answer be? As in, what number multiplies by itself 4 times to give you 81? What do you think it should be?
3.
Anybody?
3.
Okay, so let's go ahead and do that double square root again. So we do the square root of 81. So the square root of 81, guys, turns out to be 9. And then you take the square root of 9, so that gives you 3. And that's it, okay? Now, next, we're going to simplify radicals that includes the variables. Radicals with variables in there. Now, when you have the radicals with the variables, guys, it's a simple process, but you got to pay attention to it. All right, so let me go ahead and get you started. Now, on this one right here, we're looking at these type of questions. We have the square root of x to the 8th power. So, when you have a radical like this and you need to simplify it, what you do is you divide, keep the base. keep the base and divide the index into the exponent. So here, I would go ahead and keep my base x, and then I would take the index. The index here is empty, so that would be equivalent to 2. I would divide it into 8 in order to get the power that goes here. So the index is 2. I divide it into the power of 8, and 2 goes into 8. How many times? 4 times. So the answer for the square root of x to the 8th would simplify to x to the 4th power. Now, likewise, if you had the cube root of, let's say, x to the 18th power and needed to simplify this, you would keep the base x, and you would take the index of 3, divide it into 18. 3 goes into 18. How many times? 6 times. All right, you guys go ahead and try some. What would the square root of x to the 14th power simplify to? The square root of x to the 14th power. What does that simplify to? Anybody? All right. So that would give me x to the what power, guys? X to the, nobody?
Seven.
7th power, very good, okay? So what if I had the cube root of x to the 24th power? What would that one be? X to the what power? 3 goes into 24 how many times? 8 times, okay? So this one would simplify to x to the 8. Now, guys, this is easy. So now I am going to put all of this together, and we are going to practice with some of the questions from the assignment. And then I'm going to come back and mention a couple more things to you. All right, so I'm getting some of these questions directly from assignment number 23. Okay, so here's one of questions, number 2. It wants you to simplify the square root of 121 x to the 6th. So for this one right here, you want to take the square root of 121. You can plug that into your calculator. So that gives you 11. And then you keep the base x. Now the index on this one is 2 because it's empty. You divide it into the power, which is 6. So you get x to the 3rd power. And that's it. Okay, so give me a thumbs up. There's a reaction button at the bottom. Give me a thumbs up if you're okay with this one, guys. Awesome. Okay.
I'm confused.
All right, who is confused? Somebody says I'm confused.
Elizabeth, I'm confused.
Elizabeth? Okay, Elizabeth.
So
All
we
right.
leave the top the same?
Okay.
Oh, that just says number. Oh, that's just an assignment 23.
Oh, this is assignment number 23.
Oh, I'm over here like, what?
No. This is
okay.
This is the problem. That's the assignment number.
All right, I got confused for a little bit. Okay, I got it.
Okay. All right. So guys, here comes another one. This one is number 7 on the assignment. It is the square root of 16 a to the 10th b to the 18th power. So on this one right here, you want to take the square root of 16. That's 4. You want to keep the base a. You take the index, which is 2, divide it into the power, which is 10. So 2 goes into 10. How many times? 5 times. Okay. And then you want to keep the b. Okay. By the way, this is 18 right here. And you want to take the index, which is 2, and divide it into the power. 2 goes into 18. How many times? 9 times. Okay, so this would be your answer right here. By the way, you will be seeing some of these questions on the test. So hopefully you guys will be okay with this. Now number 8, and then I will talk to you about something else. Now for number 8, guys, it's a long problem, but it's doable. So it's negative 3rd root of z to the third over 216 x to the 30th power. So on this one right here, we're gonna keep the negative that's on the outside. We're gonna take the cube root of z to the third. To take the cube root of z to the third, we keep the base z. We take the index, which is 3, divide it into the power, which is 3. 3 goes into 3 once. Now, the power should be 1 here, but you don't have to write the power of 1. Because when you have a base with no power, it's understood to be a power of 1. Next, in the denominator, you're going to take the cube root of 216. Now, for the cube root of 216, what number multiplies by itself to give you 216? That would be 6. And then last but not least, you keep the base x. You take the index, which is 3, divide it into the power, which is 30. So that simplifies to the 10th power. And guys, there you go. That's the answer. Any questions? All right. Give me a thumbs up if you're okay, because I'm going to move on to something else. Awesome.
Are you gonna go over the word problem?
Yes.
Can you go over 20 and 21?
Yes, I will. Okay. Now, I
Are
have
those the
to...
word problems?
I think so.
Okay.
I have to discuss a couple more things with you guys before I go into number 21. Now, guys, this next part is very critical, okay? You cannot, okay? Cannot, I repeat, you cannot take the even root of a negative number. It's not real. So in other words, if you put the even root of a negative number on your calculator, the calculator cannot compute it. It's not real. So on this one right here, guys, we're looking at numbers like this, the square root of negative 16. If you have a calculator in front of you and you try typing the square root of negative 16 into the calculator, this will give you an error message. So for these type of problems, you would say it's not real. By the way, if it's not real, it's fake, and we call those the imaginary numbers. Now, the imaginary numbers will be at the end of the chapter. We'll discuss them. That'll be the last lesson in the chapter, okay? So here's another one. If you get something like this, the fourth root of negative 81, and they ask you to simplify this, because the negative is inside that even root, you cannot do it, guys. So this one would also be not real. However, you can take the odd root of a negative. So let me write this down for you guys. So on this one right here, you can take the odd meaning 3, 5, and so forth and so on, root of a negative number. Now, for the odd roots of the negative numbers, we're looking at something like this, the cube root of negative 8. So this one is simply asking what number multiplies by itself 3 times to give you negative 8. So this one would just be a negative 2. Likewise, if it was the cube root of negative 27, and they ask you to simplify this, it is simply asking you what number multiplies by itself 3 times to give you negative 27. I had to rewrite this, guys. All right. So what number multiplies by itself 3 times to give you negative 27? That would be a negative 3. Questions about this? So the bottom line is this, guys. You cannot take the even root of a negative. However, you can take the odd root of a negative number, right? So let me take a moment and go visit question number, I think you ladies said number 22 and 23 or something like that.
I think it's 21 and 20.
21 And okay. All right. So yeah, I need to chat about this. Number 20 and 21, I think. Because number 22 looks like a vocabulary question. So the question is simply asking that little variable inside the root is called what? Is it called, for number 22, a radical sign, a radicand, or is it the index? And we talked about that already. All right, guys. So before I head on to number 20 and 22, let me go ahead and talk about the rational exponents, and then I will go to number 20 and 22. Now, when we talk about rational exponents, we're looking at fractional exponents. Okay, so basically, the fractional exponents come from the radicals. We convert the radicals, to fractional exponents. Now, how do we do this? Here's how we do it, guys. If we have a problem in the form of the nth root of x to the m, to convert it to a fractional exponent, we keep the base. The m represents the numerator, and the n here represents the denominator of the fraction, so that this, when you convert it, becomes x to the m over n power, x to the m over n power. So the exponent is the numerator, and the index is the denominator. So if I had something like this, the cube root of x to the second, and I wanted to convert it to a fraction or exponent, it would become x to the 2/3 power. Why? Because this is the numerator and the 3 is your denominator. Okay, was there a wait? Did somebody just say wait? No? Okay. So now, guys, here are some basics that you need to know when it comes to the fractional exponents, okay? So number one, let me erase this so I can start all over again. The square root of x represents the same thing as x to the half power. So the half power is the same thing as the square root. So if I were to give you 100 to the 1/2 power, this is not asking for half of 100 and you get 50. No, it's asking for the square root of 100. And so the square root of 100 would be what, guys? Ooh. 10. So that would be 10. All right. Now, likewise, if I were to ask you what is 36 to the 1/2, this is simply asking for the square root of 36. So the square root of 36 will turn out to be 6. So the bottom line is this. You guys have to be able to recognize that the half power is the same thing as the square root. Here's the next one you guys have to be able to recognize. The cube root of x. The cube root of x is the same thing as x to the 1/3 power. So if you see anything raised to the 1/3 power, this is simply asking you to find the cube root. So if you were given something like 27 to the 1/3 power, this is simply asking, what is the cube root of 27? What number multiplies by itself 3 times to give you 27? And that would be 3. You can also type this into your calculators, guys. One more like this. If we have a -8 to the 1/3 power, this is asking us to find the negative cube root of 1/8. So this would become -2. And that's it. You're just simplifying this fractional exponent. So guys, here's the bottom line for this. You have to be able to recognize that the square root is the same thing as the half power. The cube root is the same thing as the 1/3 power. And then last but not least, you have to be able to simplify some basic problems like these, okay? So let's say I had 16 raised to the 3/2 power, and they ask you to simplify this. Remember, the 2 is the index, and then of course the 3 is the exponent. So to simplify this one of the ways to do this is to convert it to a radical. Go back to using the radicals, guys. They do help, so why not convert it back to a radical? By the way, you can also type this into your calculator. So on this one right here, since the denominator is 2, this is telling us to take the square root of 16. And then we take this and raise it to the 3rd power because the numerator is the 3. So when you take the square root of 16, that gives you 4. And then you take the 4 and raise it to the 3rd power. So that gives you 64. So in essence, 16 to the 3/2 power simplifies to 64. Any questions? Okay. Now, guys, here comes another one. Now, this one right here, that says radical equals what? The radical, as in radical, when you're doing these radicals, you can also put it into your calculator. Put it into your calculator, that's calculator, all right? So guys, here's another one. Let's say we have 27 raised to the 2/3 power. You can actually type this into your calculator, or you can convert it to radical form as the cube root of 27. The reason we're doing the cube root of 27 is because of the denominator. Denominator is the index. And then the numerator says to raise this to the 2nd power. When we take the cube root of 27, we get 3. And then you're going to take this and raise it to the 2nd power. So that gives you 9. Remember, you can always type these into your calculator. Now, for those of you curious as to how to type it into your calculator, you would do 27, hit your power key, your delta or your caret, and in parentheses, you would do 2 divided by 3, and the calculator will give you the correct answer. Now, try it, guys. It actually works. The only way you're going to find out if it works is if you plug it into your calculator, all right? So now that we're done with this, I am going to get back into the assignment, and I am going to look at those 2 questions that you guys had.
Julie.
All right. So I'm going to start with number 20. I think somebody had a big question about number 20. So let me start with 20 right here. For problem number 20, guys, they give you the Moss-Teller formula for calculating adult body surface area. And the formula is B equals to the square root of HW over 31. B is an individual's body surface area in square inches. So they want us to find the body surface area if the individual's weight in pounds is, let me see here, hold on a second. My screen is covering this. The individual weighs 133 pounds. So W equals to 133. And this individual's height is 59 inches. So we got to go ahead and figure out the body surface area. So we go into the formula. We plug in 59 for H, 133 for W, and we're going to divide all of this by 31. So guys, this supposed to be a 1 over here. It just didn't, right? So now you grab your calculators, okay? So on your calculators, you would go ahead and do 59 times 130. You know what? Let's go ahead and just do it in one step, guys. Let's grab the square root key. Grab your square root. And then you are going to, under the square root, you're going to do 59 times 133, and then divided by 31, 31. Give it a try on your calculator to see if it works out. Now, the answer I'm getting looks like this. 1.583. There's a 1 after it, but we really don't need that. Now, this answer says to round it to 2 decimal places. So we have to decide right here, guys, if we're going to change the 8 or if we're going to leave it the same. Since this is a 3 and it's less than 5, that means that we're going to leave it alone. So the answer for this one is going to be 1.58 square meters for the body surface area. And guys, when you're doing these problems, don't round them until the final answer, okay? Any questions? Those of you who are asking about this, give me a thumbs up if you're okay with it. All right, I see 1 thumbs up. Okay, anybody else?
Stop playing. That was only me. That's tough.
That was it. That was number 20.
No, I put thumbs up.
You what?
I put thumbs up.
Okay, very good. Very good. All right, guys, that was number 20. Don't forget, you guys need to go into Canvas on a regular basis and check in your attendance, okay? You need to do it for all your classes, not just my class. Make sure you do it for all your classes, guys. All right, so I'm gonna move on to number 21. Now, number 21 says this. Basal metabolic rate, BMR, is the number of calories per day a person needs to maintain life. Now, a person's basal metabolic rate, B of W in calories per day, can be estimated with the function B of W is equal to 70 times W to the 3/4 power, W to the 3/4 power. Where W is the person's weight in kilograms, you have to estimate the BMR for a person who weighs 70 kilograms. And obviously, that would reflect your W. Note, 70 kilograms is approximately 154 pounds. So guys, all you're doing is substituting in the 70 kilograms. This person weighs 70 kilograms. So you take that and you plug it into the formula for W. So 70 times 70 raised to the 3/4 power. So on your calculator, I'm gonna write down the steps on how to type it into your calculator. And they want you to round this to the nearest calorie, to the nearest whole number. So you're going to do 70 times 70. Hit your power key, your delta or your caret, whatever it might be, open parentheses, 3 divided by 4. Ooh, I should have put a division sign there. Make sure that you guys understand that's a division sign. Okay, so now you're gonna go ahead and type it into your calculators. So it is 70 times 70. Hit your power key. And once you hit your power key, you should see a parentheses automatically on some of your calculators. If you don't see the parentheses, I would put it in there. 3 divided by 4 and close off the parentheses. So this turns out to be 1,600. I'm sorry, I'm writing the wrong thing. 1,694. And make sure you guys round it correctly. So what this is saying is this, guys. A person who weighs 70 kilograms, as in 154 pounds, has to consume 1,694 calories to maintain his or her life. All right, so how you guys doing? Okay, so
Good.
Excellent. Give me a thumbs up if you're okay with this problem. I saw one thumbs up. Thank you very much. All right, there's a couple more thumbs up. So anybody else with a question on the assignment? All right, guys. Now, if you don't have any more
I do.
questions, huh?
The last one, the word one. You have to watch the video, and I don't feel like watching it.
Number 24?
Yeah.
Okay, for number 24, it says, watch the section lecture video and answer the question listed below. The counter in the lower right corner of the screen displays, let me see here, this is covering something, the example number. From example 3 and 4, in a fractional exponent, what do the numerator and denominator each represent in radical form? Oh, come on. All right, guys. So that's what I just went over with you guys. What does the numerator represent? Is it the index or is it the power? Okay, so let me write an example problem for you guys. Okay, so let's say I have x to the 3/4. Which one represents the index if I were to change this to a root, to a radical? The numerator? Which one represents the index? That number that goes inside the little root right here. Which one represents that? Is it the 3 or the 4? 4. The 4. So basically the denominator is the index, Elizabeth, and then the numerator would represent the power, okay? So you want to choose the option that says the numerator is the power.
Actually, I said the power, but I was muted, so you didn't hear me.
Okay. All right. The numerator is the power and the denominator is the index. All right.
Thank you.
Anybody else? All right, guys. So that's pretty much the lesson for today. Now, of course, if you want to keep working ahead, you can. The next time I have a lesson with you guys will be on Monday next week. I will send out an email with some tutoring times where you guys can come in and ask questions if you need help with any of the assignments. And tomorrow I plan on doing it from 12 to 3. So I will have my Zoom video open if you guys want to go ahead and just join in and have a little conversation about some of the work. On Friday, we are taking our quiz. I will be sending you a message about the quiz, which you're going to be taking on Math Excel. I will put it on the calendar for you guys, okay? So if you guys don't have any more questions, I am going to end this meeting because it is now over. And that's it. I will try and get the video to you as soon as possible, guys.
Thank you.
All right, no problem.
Bye.
Bye, guys. Have a good one.
Bye.
Bye. If you have questions, you're welcome to stay after.
I miss Sarah. I was in the bathroom.
Oh, class is over, Ethan.
I was in the bathroom.
Oh, you
I heard
went to the bathroom.
I just walked out because I didn't want to interrupt you like in the middle of something.
Okay, I got you.
Bye, Mrs. Sarah. Have a good
Bye,
day.
Ethan. Have a good one.